So welcome you all to the lecture number 8, and we are continuing the PYQ problem for the space dynamics. So let me start with the gate 16. The question is 16. The question was, let me take 55. Yeah. So see, the same question we have solved already. So let me finish this very quickly. See, again I'm saying the same thing. When the satellite is injected at altitude this much, so it is given as 350 kilometer above the Earth surface. This is above the Earth surface, right? It might be elliptical or it might be anything. It is not till now it not described. So let's suppose this is your satellite. This is your H, right? With the velocity this much. So I have already told, whenever the velocity is given in your question and if they are asking the trajectory, so if you have to blindly find two things, that is a V, this is a V given, right? V orbital or V circular, that is equal to Gm by R. So find this 3.986 into 10 to the power 14 divided by your 6378 plus 350 into 10 to the power 3. If you find this 1 by 2 or square root, both are the same, you will get as a 7.68 around. Let me calculate it once again. 3.986 into 10 to the power 14 divided by 1000 divided by 6378 plus 350.5, you will get 7.69 or 68, both are the same, kilometer per second. Fine, into root 2 times. So you will get Vp is nothing but your root 2 times of V naught. You will get 10.885 kilometer per second, right? So we are having these three velocities. This is given, this velocity and this velocity, right? So you compare, if the given velocity is greater than the Vc and the given velocity is less than Vp, then our orbit is a elliptic. And if the given velocity is greater than the Vp, that means our orbit is a hyperbolic. So now you see, our given velocity is greater than this, it is satisfying, and it is less than this, it is also satisfying. That means the trajectory for this orbit is elliptic, right? Now you see the next question of 15. In 15, it was also taken by the IIT Kanpur, so it was a little bit tough, but it is okay. It might be easy for you. So this question, when I talk about this question 34, so this is now not in our GATE syllabus. This question is not in our GATE level, so I'm not going to solve this. my own time I have never solved this problem because it is not our syllabus of our gate. So now we have to solve this 35 question. We take again it is given the same thing, you have to find the path. So you can please solve this, no need to solve this again. 35 you can find this, I'm telling you how. Your speed is given already, right? The distance is also given, that means the distance from the center, that means this is your r, this is not re plus h, this is not only h, this is your r, that means re plus h is given already. You no need to add the radius of earth or radius of Mars or anything, right? The mass is also given over here, universal gas constant is given, assuming the path also given. So you can find this easily, right? So now in 15 is there any problem? No. Now go for the 14. In 14 the problem is no question. So in also 14 there is no problem. Fine. For space dynamics. 13 no question also. 12 no question also. 11 yeah, there is one problem in 11. I think what problem it was, let me search. I have not written the problem. Okay, let me see. It is 2 marks I think, so it will be come over here. Okay. Please have patience, let me find. Yeah, it is formula. Yeah. 42. It is very good question actually. Not very good, it is very type of problem, but still it is good to make you understand. So I told it already, it is your gate 11. So now read the question carefully because it is 2 marks, so you need to work in. See, elliptic orbit, that means elliptic means what you thought is the eccentricity is less than 1, of course. If in the option, in 4 option, if someone is having the eccentricity which is greater than 1, if you perfectly neglect that option, or you can delete this option from your option mark. So now the PDC at this much, that means I have told already the radius of PDC nothing but your 400 kilometer. But in PDC you need to add the radius of Earth or radius of the particular planet. So radius is given as 6400, that means 6400 plus 400, that is equal to 6800 kilometer. At the same time it is given as a RA. Actually it is the problem similar to the one of the question we have already solved in the last lecture. It is given as 3400 kilometer, that is equal to 3400 plus 6400. Why I am adding this? You already have told you the concept behind it. 9800 kilometer, fine, above the Earth's surface, fine. For this orbit, the eccentricity and 7 major axes of the respectively are given. See, you are having RA and RP, so you can find the A value. I have told you the formula for RA and RP is nothing but your RA plus RP divided by 2. So that is equal to 9800 plus 6800 divided by 2. You will get as a A is equal to 8300 kilometer. Now you find the eccentricity. The formula for eccentricity is nothing but your RA minus RP divided by RA plus RP. So I told you one thing, whenever they ask for the eccentricity, you need to remember one box which I have already given in the last to last class, and that was your, I think, second last equation. So you remember that formula, you can solve most of the question for eccentricity. So you keep RA as a 9800 minus 6800 divided by 9800 plus 6800. You will get as a 0.18 as the eccentricity. So now see this, the first option is getting correct, 0.18 and 8300 kilometer. Okay, so in 11 only one question was there. Okay, so let's go for the 8, 10. So in 10 also, okay, it was very nice actually. It's a very important question. It may come here. Let me check the question. Actually I have not written, but it must be in last because it is 2 mark. So okay, don't focus on all the problems till now. You only focus on the space dynamics problem. You will solve, and you will be able to solve the next chapter we are going to start. You will be able to solve those problems also. So make sure you don't get hesitation or fear for this. Okay. Actually, it was a very nice question. Let me search. Yeah, this one. Read this question. It is very very important. So whenever I say something important, you mark 3 to 4 lines like this. What I am doing is, whenever you revise this concept or this problem, you tick like this, you tick like this, you tick like this, you tick like this. So you will be solve 4 times at least before going to your exam. So you will be solve problems like this, and it is very important actually. Now see, the question is given here: a spacecraft have of mass 100 kg. It means mass of a spacecraft is nothing but your 100 kg, moving at a instantaneous speed of that means dv by dt is given as dv by dt is given as instantaneous speed, means it is a v only, right? Speed, it is your 1.8 into the power 4 meter per second. Picks up the interstellar dust at a rate of this much. That means mass flow rate, that is equal to dm by dt, nothing but your 3.2 to the power minus 8 kg per second. This is called mass flow rate, right? We will study this when we will do the fluid mechanics and aerodynamics or gas dynamics in deep. Assuming that the dust was initially at t equal to 0, that means at t equal to 0 we are solving this. The instantaneous rate he is asking of retardation of the spacecraft is. So I have told you one formula, that is d by dt of mb is equal to 0. That means this is your nothing but your momentum, and this is also the Newton's second law. Actually, this is Newton's second law. Whatever that is you see F equal to ma or something, this is for constant mass. So that is not a actual formula. It is having some assumptions. This is Newton's second law. So if you differentiate this by UV rule, so m dv by dt will get plus d dm by dt will get, that is equal to 0. See, this is your mass, it is given as a 100. Okay, this dB by dt is nothing but your retardation rate, so I am giving as a d by dt, plus velocity is given as 1.8 into 10 to the power 4, 1.8 into 10 to the power 4, and mass flow rate also is given as 3 point the power minus 8 is equal to 0. So you will get dV by dt in negative, you will get around 5.76 into 10 to the power minus 6 meter per second square. So you are getting in negative, but in option there is no any negative sign in any option, right? Negative sign, but still 5.6 or 5.7. So, but still it is having the same value at least. So it is asking the retardation. Retardation means decreasing. So that is why this negative will come into retardation statement. That is why the answer is only 5.76 into the power minus 6 meter per second square, which is in option I think D or what happens? Okay, which is in option D. Fine. It is get 10. Then after we are having the 9. One question is also there. In 9, let's see what happens. In 9, one question is there. 31. 31, right? So on. Okay, let me solve this also. No, it is not like this. Okay, it is not a space conforming. 31 is 21, I think. No, okay. One question is given. Yeah, this one. It is very nice question actually. 32. It was very fantastic question, literally. Now you see 9, get 0, and mark this question as very important. This question can repeat, I think. Okay, right. Mark this question as very important. Now you see the acceleration due to the gravity of the surface of Mars is dispersed times of rate of the Earth. That means, let's suppose g is a acceleration due to gravity of Mars, that is equal to 0.38 times of 0.385 times of g of Earth, right? Given, and the diameter of the Mars is, it means, times of Earth. Diameter also, okay. And the diameter of a Mars is 0.532 times of diameter of Earth. That means radius of Mars is equal to 0.532 times of radius of Earth. We can take 2 common and we can cancel out, right? Now we are asking the ratio of escape velocity from the surface of Mars. That means the v escape of a surface of Mars to the B escape of the surface of Earth. That means B escape of the surface of Earth they are asking. Now see. So you know one formula. Let's see. You know F equal to G capital M small m divided by R square. Fine. That is also equal to m into G. This is your Newton's gravitational law, and this is your G. That means G is nothing but your Gm by R square. Fine. Because in terms of G, the things are given. That is why I am taking G. Now in escape velocity, you see the escape velocity nothing but your 2 times of Gm by R. Now what to do is you multiply by R and divide by R. What I am doing is multiplying by R and dividing by R, so it becomes 2 times of Gm R square into R, right? And this Gm by R square is nothing but your G. That means 2 times of G into R. Fine. Now you see B escape of Mars divided by B escape of Earth, that is equal to root under 2 times of G of Mars into radius of Mars divided by 2 times of G of Earth into radius of Earth. Right? These two will be cancelled out. Now keep the values 0.385, or you can say from here you can say Gm by G is nothing but your 3.85, and from here you can take Rm by Re is equal to 0.532. Now multiply these two. Put under 0.385 into 0.532. If you multiply this, you will get as 0.385 into 0.532. You will get as 0.204. That means you will get as final answer B escape of, or you can say like this, B escape of Mars to the B escape of Earth is equal to 0.45. 0.45. Is there any option? Let me check. What is happening? Yeah, 0.45. Yeah, option A is correct. So this is very important question actually, and it may come for the 2 mark, I think, or it may come for 1 mark at least in upcoming years. It may be 26, 27, 28, but it might come because it is very nice question actually. Okay, so it was 29. Then after we are having for 8. In 8 we are having question of 21. Let me see the 21 question. Yeah, 21 is very good question actually for theoretical purpose. 2008. See, now what happens? Let's see. Which of the following quantities remains constant for a satellite in an elliptical orbit around the Earth? See, kinetic energy, of course not. Product of speed and radial distance from the center of Earth, of course not. The rate of area swept by the radius vector from the center of orbit, right? And the rate of area swept by the radial vector. Till now, both are the same thing. Okay, from center of the Earth or center of the orbit, which one is correct? So we talked about this in our elliptical orbit. So suppose this is your small mass m. So from here to here, we are having some swapping, right? From here to here. So it is around the center of Earth, not from the orbit of Earth. So the option is D. D for daily is correct, right? Again, 22. Again, it is very easy problem. Okay, we'll take here. Here. Another problem is a planet is observed that it is slowest when it is at a r1 distance. R1 means what? So when this planet is very slow at the apogee. So let's suppose this apogee, that means Ra is equal to r1, right? From the sun, and it is very fasted when it is at the distance r2. So when it is fasted, it is at near the perigee. Suppose this is your r2. So now the eccentricity E of the planet of the orbit is given as. So what is eccentricity? See. That's it. Okay. The E is nothing but your Ra minus Rp divided by Ra plus Rp. What is Ra? R1 minus R2, R1 plus R2. Is it option? I think C, right? Option B is correct. This is wrong. This is wrong. This is absolutely wrong. So option B is correct. Then after gate 7, the last year of aerospace, and gate 27, or you can say 2007 was initiated for the aerospace. So let me take the question of 21. It is very cheap type problem, you can solve this. No need to explanation all these things. So now we have finished our space dynamics subject with the conceptually, by theoretically and numerically. So till now I have finished around 30 problems at least. So please go through it. If you solve all these PYQs, then no need to solve from any book or any other platform. You practice only these problems, you will understand if the problem will come into the exam, or if you give the test series, which I will provide in starting of November. If you give the test series, so you will understand all these problems very carefully. But whatever I have taught you in the space dynamics, in theories, as well as the whatever I have told you during solving numericals, everything must be clear in your mind, and you must be keep in your mind how to solve the problems and how to approach the problem. Actually think like a student, not as a teacher, because you are not a teacher. So think like a student. So thank you so much for being patience and having a good chat with me, and please feel free to contact me at this number, and I will start a new subject I think rocket propulsion I will start because these two are independent. So I will start rocket propulsion, or I will see which subject I will start. But next chapter, next lecture I will upload on Sunday, obviously, because I'm having some work in Kanpur. So next, I will upload 2 lectures or 3 lectures on Sunday, so that you can enjoy these 3 lectures in your weekdays. Thank you so much for having patience with me, and please follow this channel and subscribe this channel and share more and more to your juniors and colleagues, whoever needs this channel or needs these types of education also in a systematic way, whatever I'm teaching. So thank you so much for being patient and have a nice day. Thank you so much.